Welcome, Hornets, and thank you for joining me today. Today, we're going to be taking a look at part four to the assignment number 12, which was found on page 453. And specifically, we're looking at 41 through 48 and then 72. Please be aware I'm only doing numbers 41 through 44 and 72, and I leave 45 through 48 for you to try on your own. So please be aware in number 41 through 48, they are specifically giving you a graph. This graph has three regions in it. And we are trying to revolve about x equals 0, x equals 1 for numbers 41 and 42. Then R2 revolved around y equals 0 and y equals 1. And then 45 through 46, I'm letting you try to do on your own. And since they fit numbers 41 and 42 fairly well, that shouldn't be too much of a problem. Alrighty, let's go ahead and begin. So we're taking our first pit right here. We're revolving for number 41 around the x equals 0, which is my vertical axis. This is giving me the disk method, and I have a point here, which is 0y, and this point right here, which is y comma y, and that will give me my r of x. So here we go. Pi integration 0 to 1 of my upper minus my lower, that's y minus 0, the quantity squared, which will be y squared dy. I end up integrating, and that's going to give me 1/3 y cubed from 0 to 1, and when I plug in 1, I end up with pi over 3 as my solution. When I go to number 42, we're now looking at revolving it around the line x equals 1. So I'm going to redraw my graph. And I'm revolving around x equals 1. That's this axis right here. Once again, we're looking at this region, which means I have my upper minus lower, or in this case, right minus left, and then right minus left. This point, once again, is 0y. This point is y comma y. And this point right here is 1 comma y. So we have our big R of x, which is 1 minus 0 for 1. Our little r of x, which is going to be 1 minus y. And putting this together, I have pi integration 0 to 1 of my big R, 1 squared, minus my little r, 1 minus y, the quantity squared, dy. Now as I do this, I end up getting pi integration 0 to 1, 1 minus 1 plus 2y minus y squared dy, and the 1's cancel. This leaves me with the integration pi times 0 to 1. I have 2y minus y squared dy. Integrating, I'm now getting from y squared minus 1/3 y cubed from 0 to 1. That's going to give me 1 minus 1/3 multiplied by pi, and my answer is 2/3 pi. This brings me to number 43. Just as I did before, I'm going to make sure that I rewrite my picture. This time we're looking at region 2. It's this region right here. And we are rotating region 2 around y equals 0. Y equals 0 is my horizontal axis, or the x-axis. So if I'm rotating region 2, I once again will have this washer method. And this point right here is y equals x, so we have x comma x. This point is x comma x squared, and this is x comma 0. Notice we have a big R and a little r, so we're going to have to go through and find them. My big R of x is going to be x minus 0 for just x. Little r of x is going to be x squared minus 0. Pi integration going from 0 to 1. And I have x squared minus x to the 4th dx. 1/3 x cubed minus 1/5 x to the 5th from 0 to 1 is 1/3 minus 1/5 multiplied by pi. That's 5 minus 3/15 times pi. My answer is 2 pi 15ths. And this is now going to bring me to number 44. Once again, we're now doing it around y equals 1. That's going to be up top. The axis of rotation is now up here. Big R, little r again. This is 1 comma y. This is x comma x. Oh, wait a minute, I got that backward. That's x comma 1. And then right here we have x comma x squared. So finding my big R of x, that's going to be 1 minus x squared. Little r is 1 minus x. So pi integration 0 to 1 again. And I'm going to have 1 minus 2x squared plus x to the 4th minus 1 plus 2x minus x squared dx. The 1's are going to cancel. And I'm now looking at pi integration 0 to 1. And I have 2x minus 2x squared. Wait a minute. Minus 3x squared plus x to the 4th dx. Pi x squared minus x cubed plus 1/5 x to the 5th. 0 to 1. Pi 1 minus 1 plus 1/5. And I end up getting pi over 5 for my answer for number 44. Alrighty, we're now going to head to numbers 72. Please be aware that number 72 is pretty much a great big problem. And what they are asking you to do is perpendicular cross sections. You notice they give you figures, so they want you to work with squares, then equilateral triangles, then semicircles, and then isosceles triangles. We're going to work with the same figure, x squared plus y squared equals 4, which is a circle, and we're going to bind it into 3 dimensions. So we're going to start off in number 72 with A. A is having us work with squares. So I'm going to start off by drawing my figure in 3 dimensions. So 2, 2, 2, and 2. Drawing my figure first. Finding my segment. Drawing it as a square. And recognizing the entire side here is r of x. This entire side is also r of x. If I'm working with a square, I'm going from my values of -2 to 2, and I have the choice of doing the even rule, and I am. So 2 times the integration from 0 to 2, and you'll notice that this point right here is x comma the square root of 4 minus x squared, and this point right down here is the negative. So x comma negative square root 4 minus x squared, and that means that my r of x is going to be the upper minus the lower for 2 square root 4 minus x squared. There went my lights, of course. 4 minus x squared, the quantity squared, dx. And this is giving me 2 times 4, integration 0 to 2 of 4 minus x squared dx. This is giving me 8. I then have 4x minus 1/3 x cubed from 0 to 2, and that's 8 minus 8/3 for 16/3 multiplied by 8, and I'm getting 48 and 124/3. And that's my answer for number 72. This brings me to number 72B. That was A. We're now looking at B. So I'm going to start with the same figure, same situation. Drawing my curve. Drawing my segment. Identifying my two endpoints, x comma square root 4 minus x squared, and down here, x comma negative square root 4 minus x squared. That means that my r of x, same thing. Now keep in mind they want equilateral triangles. So if this is r of x, this is also r of x, and that's r of x. And I'm going to want to kind of break this down a little bit so I can see it more clearly. We're talking about a 60, 30, 90-degree triangle, where if this is 2a and it's equal to r of x, then this is r of x divided by 2, and that makes my height, so a root 3, so we have root 3 over 2 r of x. Now please keep in mind that this entire side is the r of x, and I'm looking at 1/2 base times height. So I have 1/2 times my base times my height, root 3 over 2. And then I have the integration from, let's go 0 to 2, and I'm doubling it. And I have 2 of these square root 4 minus x squareds as my side squared. Those cancel, leaving me with a 2 root 3 outside, integrated 0 to 2 of 4 minus x squared dx. And I'm now ready to begin. And as I do, I'm looking at 2 root 3, and I have my integration. That's 4x minus 1/3 x cubed from 0 to 2. That's going to give me 2 root 3 multiplied by 8 minus 8/3. That's giving me 16/3. multiplied by 2 root 3, and my answer is 32 root 3 thirds. And that's B. Alrighty, we're now going to turn the page and we're going to go to the next one. The next one was a semicircle. Semicircle was C. Once again, we're starting off at the same picture, same place. Drawing my circle in. Whoops. A little bit skewed there, but that's okay. We don't want to worry about that. Putting in my segment and my semicircle. Now you'll notice the r of x that we have here is the diameter, and it is also the same construction that we had before. That means that the r of x that I'm working with is 2 of these 4 minus x squareds. And I'm looking at the formula, pi over 2 multiplied by 2, so I can go 0 to 2, and I have pi r squared. So I have 2 square root 4 minus x squared dx. Now in this, we have to make sure this is my diameter. And diameter needs radius divided by 2 to get r. Therefore, I'm dividing by 2. So I now have pi, 0 to 2, and this is now the square, which leaves me with 4 minus x squared dx. Pi, 4x minus 1/3 x cubed from 0 to 2 gives me 8 minus 8 thirds multiplied by pi, and I'm ending up with 16 pi over 3 as my answer. This now brings me to the isosceles right triangle. Let's just look at what that means. Isosceles means that these two sides are going to be congruent. And I need a right triangle. So we have that. Now if I extend this down, I'm now looking at a 45, 45, 90, where here I have A. So if this is A root 2. So if this right here is my A value, let's just think about this. So if that's A and it's A root 2, this has to be A over root 2, A over root 2. Let's call it A root 2. All right, let's stop and think about this for a minute. So if this is entire side, this has to be, so this is 2 root 4 minus x squared, and this height is going to have to be root 4 minus x squared. And I'm looking at 1/2 base times height. So I have my base times my height. And I want to go from 0 to 2 again, so I'm going to double it. That's going to get rid of these, leaving me with 2 integration 0 to 2 of 4 minus x squared dx. So I'm looking at 4x minus 1/3 x cubed from 0 to 2. That's 8 minus 8/3 multiplied by 2, and that's going to give me 16/3 multiplied by 2 is 32/3. And there is number D. Now, please remember, I'm getting this from my hypotenuse in the sides, a root 2. And if this is r of x, then I have r of x over root 2 is the a value that I'm allowed to work with. Okay? So just be aware that's what's happening. Alrighty, and let's just move on. And I think that's it. Wow, that was our 72. I do want to just go back and double check my answers. I think that's always wise. And that is what we have. So we did get that correct. Alrighty, thank you very much. I hope this was helpful. And if you felt that this was a good video, please feel free to click like. If you have suggestions on how I can improve, please give me some suggestions. Thank you very much. Be well and be safe and take care. And thank you for putting up with all 4 parts of this video. Bye-bye now. Be well, Hornets.